Okay, the next conic section we're going to be talking about or discussing here is going to be the ellipse. When you take a plane and pass it through a cone at an oblique angle, which means not at a right angle to the transverse axis here, that is going to generate your ellipse. And you can see that right here. All right, so there are two formulas for your ellipse. One is when you have a horizontal orientation, so on your graph it's going to be longer horizontally, and then a vertical orientation, which means on your graph it's going to be longer vertically. Now, if you'll notice these two equations and compare them, really the only difference between these two equations is the a and the b have been switched, the a squared and the b squared. So here the a squared is underneath the x's, and the b squareds are underneath the y's. And here the a squared is under the y's and the b squared is under the x's. So how do you tell which equation is going to be which when you put all the numbers in? Well, what you're going to look for is the a value. A is always going to be greater than b. And what that means is that when you have an equation here, you're going to have some numbers in your denominator. Whichever denominator has the largest number, that's where your a is going to be found. Okay? And so if your larger number is underneath the x's, that means you're going to have an horizontal orientation. So it's going to be longer in the x direction because the larger number is under the x's. If the larger number is under the y's, then it's going to be longer in the y direction, which is a vertical orientation. Okay, so that's what you're going to be paying attention to. Now, if you'll notice in the equation here, a is the distance from here to here, and b is the distance from here to here. And then a is this way on this one, and b is this way on this one. So you'll notice that a is not always the horizontal one. A is the longer of the two segments. Okay. All right, so coming over to this diagram, some things that we can label on your ellipse. Start with your axes. The major axis is the segment going from one vertex to the other vertex. All right, so your vertices are on the ends of the major axis, and the major axis is always the longer of the two axes. The minor axis is this one right here. And the endpoints of the minor axis are called your covertices. So vertices on the ends of the major axis, covertices on the ends of the minor axis. Where the axes cross is called your center, and then you have a focus on each side. Plural for focus is foci. All right. So A, that is the distance from the center to the vertices. All right, so just like we showed on the previous page, A was the distance from the center to the vertex. Center to the vertex, because remember your vertices are always on the ends of the major axis. All right, so from here all the way to here, that distance is going to be A. B is the distance from the center to the covertices. So the distance from here to here is going to be your B value. And the distance from the center to the foci on the major axis, from here to here, that value is going to be C. Okay. So So those are going to be important. Now what if you're only given 2 of those values and you need to find out what the third value is? Well, that's where this formula will come into play. In their equation, c squared is equal to a squared minus b squared. That's the relationship between those 3 lengths. All right. So let's come over here and take a look at an equation. Now, this equation has already been put into the format that we need, which is these 2 right here. And these are just some steps outlined to take a look at how we can graph this thing. Starting out, your equation has to be set equal to 1. That's important right there. So very first thing, make sure you set your equation equal to 1. Now if you have some number other than 1 over here, your first step is going to be dividing that number to the other side. You're going to divide everything by that number, whatever it happens to be. All right, this equation is all set up though, so we don't have to do anything with that first step. Second step, determine the center. The center is still HK, just like it was with the circle. So the center on this point, or on this ellipse, is going to be -2, +4. And that is graphed right here. Next it says determine the A value. Well, look at your 2 denominators. You have a 9 and a 25. The larger of these 2 numbers is 25. And remember it says over here A is greater than B. Okay. So this number right here is A squared. Okay. So you can see right here, denominator is A squared, and that's where we have our 25. What that means is that A is going to equal 5. Graphically, it means that you are going to go 5 units in the y direction because it's underneath the y's. So from the center, which was -2, 4, you're going to go 5 units up, put a point, 5 units down, put another point. Those are your vertices. Next step, determine your b value. Well, the b value is b squared is the smaller of the 2 denominators. That's b squared, which means b is equal to 3. And so since that's underneath the x values, from the center you're going to go 3 to the left and 3 to the right. Those will be called your covertices. Fifth step, determine the c value. C, if you'll remember from the other page, is the distance from the center to the foci. All right, so that's these points here. All right, so, and the relationship is c squared equals a squared minus b squared. So c squared equals a squared, that was 25, minus b squared, which is 9. So c squared equals 16, giving us c is equal to 4. And the foci are always on the major axis. So we're going to go 4 units up and 4 units down because this is your major axis. And these will be your foci. Alright, sketch your ellipse going through the vertices and covertices. So once you have all those points on your graph, then all you're doing is drawing your ellipse or sketching your ellipse going through those points. Okay. So just labeling everything here. This is a vertex. This is a vertex. This is a co-vertex. Same thing over here. It's a co-vertex. This is a focus. This also is a focus. And this is your center. Okay. All right. Now let's do one without the steps written out. All right, so a value. Look for your larger denominator. This is a squared. So a is 7. B, well, the other denominator is your b squared, which means b is 5. C, if you use your equation, c squared equals a squared minus b squared. So a squared was 49, b squared was 25, giving you c squared is equal to 24. So c is equal to the square root of 24, which if you simplify that, comes out to 2 root 6. All right, the center of the circle, that's your HK, which is going to be -4, +1. Okay. All right, so let's plot everything here. 1, 2, 3, 4, 1. There's our center. Everything goes from the center, so you do that part first. Now your A is going to be under your Y's. That means we're going to go 7 units in the Y direction. So you're going to go 1, 2, 3, 4, 5, 6, 7 up. 1, 2, 3, 4, 5, 6, 7 down. The B's are underneath your X's. So you're going to go 5 units in the X direction. So 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. 5 units in the B direction, or in the X direction, I mean. All right, we can go ahead and sketch a graph of our ellipse. And the other thing to put in here is going to be your foci. 2 square root of 6. Well, that's just a little bit less than 5. Okay, 2 times the square root of 6. So that means we're going to go 1, 2, 3, 4, 5 along the major axis. And that's where your foci will be. All right, domain is from left to right. Just like circles, your domain and range will always have brackets. So our center was right here at -4, 1. And then from the -4, we went 5 units this way, which puts you at -9. And then we went 5 units this way, putting us at +1. The range, well, this is a y value of 1, and we went down 7 units, putting you at -6, and then you went up 7 units, putting you at +8. All right, so the next problem. Find the following information about this graph. If you remember from the other page, the very first thing that we have to do is set our equation equal to 1. Okay. That has not been done on this problem yet, so we need to do that. We're going to divide all of these by 144. Okay. All right. Now, 16 divided by 144. What does that come out to? Okay. Well, that comes out to 9. So this is going to become x plus 2 squared over 9. because this reduces once and 9 times. This will just stay plus y squared over 144 equals 1. So now the a value. The larger number is underneath the y's, so this will be the a squared, which means a is 12. The smaller number is your b squared, which means b is 3. And c we get from a squared minus b squared. So that is going to be 144 minus 9. So c squared is 135. So c is the square root of 135. All right, the center is hk. That would be negative 2, 0. Your domain. Well, let's graph what we have first of all. Center is at negative 2, 0. In the x direction, we're going to be going 3 units. So 1, 2, 3, 1, 2, 3. So that's going to put you at negative 5 and positive 1. In the y direction, you're going to go 12 units. So you're going to go up 12 and down 12. So that gives you your range. We can sketch our graph here. And we can take the square root of that, which is going to be a little less than 12. It's going to be out here. And that's about all that we need for this. All right. Hope you're successful with your ellipsis.